Good evening, guys. Sorry I have been gone recently, but things happen. So we're just gonna get right into it. This is chapter 11, the very beginning. We're gonna call this 11.1 polynomials. Okay, so first we're gonna start off with this thing called a monomial. So our first vocabulary term is this thing called a monomial. And what it is it could be a real number, a variable, or a product of a real number and a variable. A real number, a variable, or a product of a real number and a variable. So examples of monomials would be like 6, 2x, 3x squared y, 2.5 x to the fourth, or like a divided by 3. Okay, so real number, variable, or them put together. Okay. What you can do is you could talk about this thing. The next vocabulary term we're going to talk about is a degree. A degree is the sum of exponents on the variables in a monomial. Okay, so let's look at this one. This one right here, actually we better do a little bit more vocabulary before we do that. So we're talking about degree. The degree of a constant number that is not 0 is 0. So what I mean by that is that this guy has a degree of 0. There's no variable attached to him, so he has a degree of 0. This guy over here, this guy has a degree of 1 because of the variable. This guy, since there's an imaginary, not imaginary, but there's a 1 that you can't see, the degree of this one is the sum of exponents on the variables. Remember, sum of exponents. So it's 2 plus 1, which is 3. This degree would be 4. And this degree would still be 1. One more thing, 0 does not have a degree. Sad face for 0. So that's monomials so far. So what we can do is we can take these, and we don't just have to be restricted to just one monomial. We can do a little bit more. We can add or subtract. And what we do with those, we call those polynomials. Polynomial is the sum or difference of 2 or more monomials. Okay. But when we write polynomials, there's a certain way we have to do it, and this is called standard form. Okay, standard form is where the degrees decrease. Sorry, the degrees of the monomials decrease from left to right. So an example of a polynomial would be like 2x to the fourth power plus 3x to the third minus x squared plus 1. Okay. This is a polynomial because we have 1, 2, 3, 4 different monomials all put together. And it's in standard form because these guys are decreasing from left to right. And you can't see this, but his degree is 0. Yep. So we can add polynomials together by doing this thing called combining like terms. Okay, so let's say you got something like 2x squared plus 7x squared. So we have 2x squareds paired up with 7x squareds. 2x squareds matched with 7x squareds gives us a grand total of 9x squareds. It's very important to note that the only reason I can add these guys together is because they have the exact same variables next to them. If this was something like 2x squared plus 7x, well, guess what? Can't combine that. That's about as simple as it can get. It's the exact same thing. You would not be able to simplify this expression. On the other hand, however, let's say you got something like 3x squared y minus 2x plus 4x squared y minus 7x. So what I'm going to do is I'm going to take these guys and I'm going to put them underneath their like buddies. So I'm going to put plus 4x squared y right here. I'm going to put minus, remember to take that negative sign, minus 7x. And I'm just going to worry about this now. So 3 plus 4 gives me 7 x squared y's. And negative 2x minus 7x gives me a minus 9x. And that's how I would add polynomials. Okay. But now that we have more than one monomial here, okay, there's 2 of them in this polynomial. How can we tell which one, what the degree is? If there's 2 separate ones. Okay. The way we do that is we say the degree of any polynomial is equal to the degree of the greatest monomial. The degree of any polynomial is equal to the degree of the greatest monomial. Okay, give you guys time to finish this up. Okay, so remember, if you've got something like 2x to the third power minus 2x squared plus 4x minus 9, and this is in parentheses, and you're subtracting negative 3x to the third power plus 2x plus 4. If you see a negative in front, remember to distribute this negative. It has to go to every term on the inside. So this turns into negative times a negative is a plus 3x to the third power minus 2x minus 4. And now I'm going to take these guys and move them over so I can add like terms. So 3x squared, it's positive, minus, there's no x squared, so I'm just going to put a 0 there, just as a little placeholder, minus 2x minus 4. So 2 plus 3 is 5x squareds. 2x squared minus 0 is negative 2x squared. 4x minus 2x is just a positive 2x. Negative 9 minus 4 is a negative 13. And that's how we add polynomials. Okay. Do your best, be respectful of the teacher, clean up after yourselves. I will see you guys tomorrow.